Oh, yeah.
What are you doing?
Oh, I'm trending on my likes on old Facebook, Instagram, tweet, chat.
Well, I'd like you to stop.
All right, so let's talk about an actual trend, not some silly social trend. So on the periodic table, there's trends all over the place, and it happens whether you're going horizontally across or up and down vertically, okay? So the first trend we are going to look at is going to be our atomic radius. And atomic radius actually increases from left to right across the periodic table. And then our other trend, and if I can get it here, I'll bring it up for us here. Our other trend that we have is going from the top going down. So atomic radius increases from left to right across horizontally and vertically from top down. And atomic radius is just the size. Think of each element as a certain circle, and no two circles are exactly alike, as you can see here on this kind of color-coded circle. They may be close, but no two elements have the exact same radius, if you will, atomic radius. So why does this change? Well, if we're looking vertically up and down, remember that each element has a certain number of rings, if you will. And so remember the first element, lithium, that is on the second period over here. If I can draw a little two right there. The first one being 1 for hydrogen, 3, 4, 5, 6, and there's actually a 7th. Remember, those correlate to our periods, and there are actual rings. So if I look at lithium, lithium's on 6, so it actually has 1, and it actually has 2. So the more rings you have, the further you're getting away from the nucleus and that attraction of the protons in the nucleus. Think of the protons as a magnet, okay? They are our electron magnet. So the more protons you have, okay, which are positive, they are attracting electrons, which are negative, right? It's like putting two opposite ends, positive, negative, a magnet together, they attract. But if you put likes, they repel. So the electrons will be closer together. If I look at sodium, sodium is over here on my period 3, if you will, right there. So how many rings will it have? Well, it'll have its first one, it'll have a second one, and it'll have a third one. So it has even more rings further away from the nucleus. And then finally going down to potassium, potassium is here on our 4th level right there. So how many rings will it have? 4. So it has its first one, has another one, and finally its innermost or lowest energy right there. So it has 4. So the more rings up and down vertically, that makes it larger. But if you're looking across the periodic table, you're going, well, Mr. Armstrong, from sodium over to all the way over here to silicon and across, notice they're all on the 3rd period, if you will, here. They're all going to have 3 rings. So why do they keep getting smaller, or the atomic radius getting smaller as you move across? Well, that has to do more with the protons, okay? So if I look at sodium, sodium has 11 protons in the nucleus, which are positive, right? So it has like the strength of 11, if you will. What does aluminum have? Aluminum now, if you move across, actually has 13 protons. So it has more, it has a stronger magnet, if you will. And then finally, silicon, what does it have? You had one more, has 14 protons. Well, you just made that magnet stronger, which is attracting or squeezing in, pulling all those electrons that are out here in the rings closer to it, if you will. So that number of protons we actually call the nuclear charge, okay? The nuclear charge. And the greater the nuclear charge, the greater the attraction for the electrons, okay? So if you have a greater nuclear charge, the more protons you have, the greater nuclear charge or attraction of the electrons. Know that. All right, let's talk about our next trend, if you will. It's called electric electronegativity. And folks, can't emphasize enough, you need to know this trend. It is the most important of all the ones we're going to talk about because it's going to keep coming up the entire year. Electronegativity. So what is it? Well, you need to know it's the attraction for an electron where in a chemical bond. Most important, when two elements are chemically bonding, who's attracting that electron more? Whoever has the greater electronegativity value or trend. And so if we look at the periodic table, they actually have those values. And so if you look here, who has the highest value? Well, that would be fluorine is the highest electronegative element on the entire periodic table. Whereas if you look down here, cesium has the least. So let's say those two were going to bond with each other. Who's going to have the greater attraction for those electrons? Because that's what they're doing. Somebody is giving or taking or sharing of electrons. Well, fluorine is the most electronegative, so it's going to be the big bad electron hog. And it's going to want to take, what's cesium going to want to do, or rubidium? It's going to give it away because I'm not fighting with fluorine. So you have to know the values, but just a general trend on the periodic table, how does electronegativity work? Well, it increases from bottom up, and this time it increases from left to right on the periodic table, okay? That is your trend if you're looking from element to element. Notice, there's some elements that have the same value, but very few, so you have to really look at the trend and know who's going to be that big bad electron hog, okay? So write down that term, electronegativity. Okay, our last trend here is ionization energy. Remember, what is an ion? Ion is gaining or losing of electrons. But we're actually looking at the energy it takes to gain or lose, in this case, lose that outermost electron in the outermost shell. So you need to have the definition here. It's the energy it takes to remove an electron. I'll give him a little dash here. Remove an electron from the outermost shell. So if you look here, potassium here has one valence electron. So it's that energy it takes if some other element wants to take it when it's bonding with it. What energy does it take to get that? And so if we look at the trend on that on the periodic table, it works very similar to our electronegativity in the fact that it increases from our bottom up and from left to right. So from the bottom moving up and from left to right. So who has the highest, who's going to require the highest ionization energy? Well, that'd be those elements all the way on this side. Whereas these elements over here, it doesn't require as much energy. If they're wanting to get rid of it, they're like, hey, just take that electron. We don't care. Where the fluorines and over in here, they're never going to give up an electron because it's going to require way too much energy, right? It goes hand in hand with electronegativity where they're highly attracting those electrons over here. Remember, fluorine has the highest electronegativity of any element. So those are our three trends. You need to know them. You have atomic radius, you have electronegativity, the most important, and you have ionization energy. Know all three of these trends.